one more application of oxidation number, that is to find the equivalent weight, and there is a law also known as law of equivalence. So how do these are getting applied to the Redox systems, that I will tell you in this part. And also I will do a question on these concepts. So let's start it. So our next topic, guys, is equivalent weight and law of equivalence, which is, the quantitative aspect of this chapter. So before that, we must know what is n factor. What do you mean by n factor? Okay. So n factor is, in redox reaction we say, it is equal to the number of moles of lost or gained electron per molecule. Means in redox reaction, you know that there is addition or loss of the electron, right? Addition or reduction of the electrons. So what is that number during that whole process of one simultaneous equation? That is your n factor. And n factor of substance in a non-redox reaction is equal to the product of displaced mole and its charge. So don't worry, we will only deal with redox reaction here. So for acids, the number of moles of replaceable H plus is known as your n factor. Okay, is known as your n factor. So for HCl, I can have only one H plus, so that's why n is 1. For H2SO4, I have 2. H3PO4, I have 3. So let me write it here. For H3PO3, I will have n is equal to 2. It depends upon that structure. Now for bases, the number of moles of replaceable OH ions is per mole. Okay, OH ions, here in acids I was talking about H plus ions. In bases, I will be talking about the hydroxyl ions, OH negative ions. Okay, so for NaOH I have only n is equal to 1. For barium hydroxide I have 2 OH ions, so that's why my n will be equal to 2. And similarly, in aluminum hydroxide I will be having n value equal to 3. Okay. Then next topic is equivalent weight. What is equivalent weight, guys? So molarity, we know that molarity is number of moles of any solute particle dissolved in per liter of that solution. Normality, we know number of gram equivalents divided by the volume of the solution in liters. Now what is gram equivalence, guys? Your gram equivalence of any solute is equal to the weight of that solute, whatever you are taking, divided by the equivalent weight. So this you have to understand that what exactly is equivalent weight, because without this there is no meaning of normality, right? How do we calculate the normality? So equivalent weight is actually molecular weight divided by the n factor. So n factor, you understood how to calculate of acids and bases. Also in redox reaction, the number of electrons which will be gained or lost per mole. So gram equivalence is equal to n into number of moles. So your normality from this equation will be equal to n times of molarity. Now law of equivalence, what is this law? According to this law, the number of the gram equivalents of all the reactants are equal to each other in a reaction, assuming none of them are in excess, and is also equal to the number of gram equivalents of all the products, again assuming that the reactants are undergoing the reaction in that reaction. Okay, so this was a statement. So whenever I obtain my equivalence point, then I just equate the gram equivalence of both the sides and then just find that whatever is asked in the question. Okay, that I have to do here. Now this will become more clear by this question, that H3PO4 being a tribasic acid. Okay, I told you n is equal to 3 here, and one of this salt is NaH2PO4. Okay, sodium hypophosphate. Now what volume of 1 molar NaOH solution should be added to 12 gram of NaH2PO4 to convert it into Na3PO4? Now for this type of question, what we can do, we can just apply the law of equivalence. Options are also given. Okay, let's solve this question so that you can better know that what I'm trying to deliver. So I'm trying to say that you have to apply what? The law of equivalence. What was the statement? The statement was whenever I obtain the equivalence point, then I have to equate them. So here equivalence point will become when my equivalence of equivalent weight of NaH2PO4 that is equal to my equivalent of NaOH. Okay, then only I will say that this has obtained my equivalent point. So from this I can say 12 by m into 2 that is equal to 1 into V into 10 raised to the power minus 3, right? So this implies, I think from here if we will calculate, then your V will come out to be 200 milliliter. So the correct answer for this question will be option B. Option B will be the correct answer for this one. So now I hope that you have understood that what is equivalent point, what is the law of equivalent statement, okay? What is the law of equivalent statement? Hey students, so I told you about the equivalent weight, what it is, how do I calculate my equivalent weight. I told you about the law of equivalence. Also we saw the same thing with an example question. Now with that concept of equivalent weight, we can use that application of equivalent weight in finding different concentration, and this is how we proceed to the titration reaction, which I'm just going to proceed for my next part. So in the next part I will be telling you something about redox titration, so stay tuned with me for that.